Welcome to Star Chat, the podcast that explores the wonders of the universe and brings you the latest news from the world of astronomy. I'm your host, Carl, and I'm thrilled to have you join me on this journey through the cosmos. As we gaze up at the night sky, we're often reminded of the beauty and complexity of our celestial neighborhood. And one of the most iconic and awe-inspiring sights in the sky is the moon. Our closest celestial companion has been a source of fascination for humans for centuries, and tonight, we're going to talk about the best time to observe it. But before we dive into that, let's set the stage. The moon orbits our planet at an average distance of about 239,000 miles, taking approximately 27.3 days to complete one cycle around the Earth. This means that the moon appears to change its phase as it moves through its orbit, presenting us with a constantly changing face. Now, when it comes to stargazing, the moon can be both a blessing and a curse. On one hand, its bright light can illuminate the night sky, making it easier to spot certain celestial objects. On the other hand, that same brightness can overwhelm the faint light of more distant stars and galaxies, making them harder to see. So, what's the best moon phase for stargazing? Well, as our friends at earthsky.org point out, it really depends on what you want to see. If you're interested in observing the moon itself, then any phase will do. You can watch as it waxes and wanes, growing from a thin crescent to a full, bright disk. But if you're looking to explore deeper into the universe, then you might want to avoid the moon's glare. For telescopic observations of faint objects like galaxies and star clusters, it's often best to wait until the moon is in its new phase, or is below the horizon. However, with the advent of modern technology and image processing techniques, many amateur astronomers have discovered that they can still capture stunning images of the night sky, even when the moon is present. By using special filters and stacking multiple exposures, it's possible to remove much of the moon's glare and reveal the faint details of distant celestial objects. As we explore the universe, we're constantly reminded that there's no one-size-fits-all approach to stargazing. Whether you're a seasoned astronomer or just starting out, the key is to be flexible and adapt to the changing conditions of the night sky. And speaking of change, did you know that the moon rises about 50 minutes later each day? This means that if you want to follow the moon through an entire lunar cycle, you'll need to observe it at slightly different times each night. It's a great way to develop a deeper appreciation for the moon's phases and its place in our celestial neighborhood. So, which moon phase is best for stargazing? The answer, as we've seen, depends on your goals and interests. But one thing is certain: with a little planning and creativity, you can make the most of any night sky, regardless of the moon's phase. We'll be right back with more fascinating space news on Star Chat. Welcome back to Star Chat. I'm your host, Carl. We're exploring the wonders of the universe and the latest developments in space exploration. As we delve into the world of astronomy, we often talk about the exciting discoveries and missions that are helping us better understand our cosmos. However, today, we're going to discuss a rather concerning topic that affects not just the future of space exploration, but also the advancement of science as a whole. Imagine a universe where budget cuts dictate the fate of groundbreaking missions, where the pursuit of knowledge is hindered by financial constraints. Unfortunately, this isn't a distant hypothetical scenario. It's the reality we're facing with the proposed NASA budget cuts for fiscal year 2026. The White House has put forth a proposal that would slash NASA's budget by about a quarter, down to $18.8 billion from nearly $24.9 billion in fiscal year 2025. This isn't just a minor adjustment. It represents the sharpest year-over-year cut proposed for NASA, bringing the agency's budget down to levels last seen in 1961, when corrected for inflation. But what does this mean for space exploration and the scientific community? The impact is profound. With these cuts, jobs will be lost. A third of NASA's direct-funded civil servants could see their positions eliminated, dropping from 17,391 to 11,1853. Moreover, The budget proposal targets the Science Mission Directorate with a staggering 47% cut in funding. This isn't just about numbers. It translates into the termination of productive spacecraft, delays or cancellations of development projects that were on budget, and reduced opportunities for future scientists and engineers. Missions like New Horizons, which has given us breathtaking insights into Pluto and the outer reaches of our solar system, are facing cancellation. The OSIRIS-APEX mission headed to asteroid Apophis, Juno's exploration of Jupiter and its moons, all these and more are under threat. It's not just about losing a few missions. It's about stifling innovation, killing spin-offs, startups, patents, and the talent pool that drives global influence in science and technology. The Planetary Society has aptly described this as an extinction-level event for Earth and space sciences. They're sponsoring a petition, open to anyone around the world, to voice opposition to these cuts. If you care about the future of space exploration and the advancement of science, now is the time to make your voice heard. You can contact your representatives in Congress and express your support for NASA's budget. As we navigate this challenging landscape, it's essential to remember that the pursuit of knowledge and exploration is a fundamental part of human progress. These proposed cuts are not just about NASA or the United States. They have implications for global scientific collaboration and our collective future. Stay tuned for our final story of the day, right here on Star Chat. Welcome back to Star Chat. As we conclude another fascinating episode, I'd like to take you on a journey to the outer reaches of our solar system, where a mysterious and elusive world has captivated the imagination of astronomers and space enthusiasts alike. Today we're talking about the possibility of a Planet 9, a hypothetical planet that's believed to be lurking in the distant, dark recesses of our cosmic neighborhood. As we've discussed before on this show, the search for Planet 9 has been an ongoing effort, with scientists using a variety of methods to try and detect its presence. And now, new research suggests that wide-orbit planets like Planet 9 might be more common than we thought. In fact, they could be a natural result of the early chaotic years of a developing planetary system. Imagine a time when our solar system was still in its formative stages, with giant planets colliding and scattering smaller objects into distant orbits. This process, known as dynamical instability, could have created a wide-orbit planet like Planet 9, which would have been trapped by the gravitational influence of nearby stars in the cluster. The researchers behind the study used sophisticated simulations to model the evolution of planetary systems, and their findings are nothing short of astonishing. They discovered that solar system-like systems are particularly efficient at trapping wide-orbit planets, with a probability of 5–10% Dodge gap. This means that for every 1,000 stars out there, we might expect to find one wide-orbit planet. But what does this mean for the search for Planet 9? Well, it's a game-changer. The study identifies promising new targets for exoplanet hunters, suggesting that wide-orbit planets are most likely to be found around high-metallicity stars that already host gas giants. This makes these systems prime candidates for deep imaging campaigns, and the Vera C. Rubin Observatory is expected to play a key role in this search. As we refine our understanding of where to look and what to look for, we're not just increasing the odds of finding Planet 9. We're opening a new window into the architecture and evolution of planetary systems throughout the galaxy. It's an exciting time for astronomy, folks, and I'm thrilled to be sharing this journey with all of you. So, as we gaze up at the stars tonight, remember that there are still many mysteries waiting to be uncovered out there. The search for Planet 9 is a reminder that our universe is full of secrets, and it's up to us to explore, discover, and push the boundaries of human knowledge. That's all for today's Star Chat. Remember to like, share, and subscribe. And until next time, remember to keep looking up at the stars.